So this is the lab lecture of the procedure for the reduction oxidation titration in general chemistry 2. This is the first of our labs that we're really going to be also focusing on safety. The chemicals we're using for this lab are hazardous, and so prior to doing this lab, you'll be reading through safety data sheets, SDSs, and answering questions based on that about their safety concerns. So for this lab, we will be using nitrile gloves like normal. And if during the course of the lab you get chemicals, lots of chemicals on them, more than just a drop or so, where they become discolored, those need to get taken off and replaced. All paper towels and gloves that are used in this lab that get excessive amounts of chemicals on them, those need to be placed in a separate container other than the trash can. If there's just a small amount of chemical on them, they can go in the trash can. But if gloves or paper towels have lots of chemicals on them, there'll be a special place, and you will be shown that when you're in the lab. So part A for this lab reminds you of the safety concerns and talks you through some of the safety concerns specific to our room and this lab. So potassium permanganate, which is the dark purple solution you'll be using for this lab, is the one that we have to be the most careful with. So at any time, you should never have more than 150 milliliters of potassium permanganate. So if you don't have more than 150 milliliters, that guarantees that if there's a spill, it will not be more than 150 milliliters. If potassium permanganate spills in excess of a drop, so if more than just a drop spills, we need to spray the spill with oxalic acid before it is wiped up. So don't directly wipe up potassium permanganate. First, it needs to be sprayed with oxalic acid, and then that mixture can be wiped up. That is true anywhere in the lab on any surface. Okay. Wear old clothing for this lab. If your clothes get potassium permanganate on them, you will be asked to take off those clothes and put on something different. We will have scrubs, so some, loose-fitting things that you can change into, but if you're really concerned about it, having a backup shirt or a backup pair of pants is not a bad idea. This is not something that happens commonly, but it has happened enough times that it's worth mentioning. Okay, so spills of potassium permanganate, which is the purple stuff, must be cleaned up by being sprayed with oxalic acid and then wiped down with paper towels. Spills of sulfuric acid should be cleaned up. If it's a very small amount, like just a drop or so, it can be cleaned up with paper towel and deionized water. But if it's more than that, we have acid neutralizer. We will pour on the sulfuric acid to clean it. Now, when these spills have happened are actually most often on our hot plate. So when we do this titration, and I'm going to explain more here in a second when we go through the procedure, your hot plate will be on heating, and the stir function on the hot plate will be what is used to stir the stir bar. Because our solution is endothermic, which means it needs to absorb heat, so we have to put it on the hot plate. So it is heating it while it stirs it. Okay, so the stir function on our hot plates, it's almost like it doesn't get used enough, so it's really, really excited about its job. So it stirs, like even the lowest speed of the stir function is still super duper fast. So sometimes we see little splatters come out. Little splatters are okay, but if we see lots of splatters, then we'll turn off the stir function and have to kind of just alternate, turn it on, turn it off, turn it on, turn off, so it doesn't get bad. Because what we don't want is to have very much sulfuric acid end up on the surface of the hot plate. My hot plate is not on right now, which is why I'm able to touch it. You're not going to be touching yours when it's warm. But we don't want any chemicals to spill on the surface of the hot plate while it's warm. Sulfuric acid, if too much sulfuric acid spills onto this, you'll be able to smell sulfur dioxide. It's gonna decompose, and we'll be able to smell sulfur. That's bad. We will have to evacuate the room until the fume hoods are able to circulate enough to remove those scents. Potassium permanganate, which will be in the burette, we don't want that to spill onto the hot plate either. So let's say the potassium permanganate spills on the hot plate. That's a spill of potassium permanganate. So you will spray it with oxalic acid and then wipe with a paper towel and rinse with deionized water. So I will be happy, or your instructor will be happy to help you with that sort of thing. But the best case scenario is just to not spill anything on the surface of the hot plate. Okay. So I would also make sure that you don't have any valuables with you. Make sure your cell phone is in your bag somewhere else. You don't want that on you. We've had people that put their cell phones on the lab bench. spilled potassium permanganate and it got on their cell phone, because of the hazards with potassium permanganate, that cell phone became chemical waste, got put in the waste container and was picked up. The student lost their cell phone because they had it out and they got a carcinogen, something that causes cancer, on their cell phone, and we could not let the student leave the room with that. So lab manual, pencil, calculator maybe with you when this happens, so that way nothing hazardous gets spilled. Okay, so we will have the fume hoods on. We will have the snorkels on to have the air circulating, so that way, you know, any sort of bad vapors, which there's not a scent, but just it's more if anything spills, is constantly going during this lab. So let's talk about part B, which is when we actually start the experiment. You're going to be doing titration. So it's going to be very similar to the NaOH KHP titration lab. The differences are it's a redox titration instead of an acid-base titration. And the chemicals we're working with are significantly more hazardous. So the two reactants for this lab are sodium oxalate, where the oxalate is the thing that's reacting, and the potassium permanganate, where the permanganate is the thing that is reacting. But this solution has to occur in acidic conditions. So instead of water used to dissolve the sodium oxalate, it'll be 1 molar sulfuric acid that is used. So the three reactants we're using are sodium oxalate, which is a solid, sulfuric acid, which will dissolve the solid, and potassium permanganate, which will be in the burette. So you will start by measuring out between 0.1 and 0.15 grams of sodium oxalate onto a piece of whey paper. And then that whey paper, you will be transferring that solid using the whey paper into a 250 milliliter beaker. We're going to be using beakers instead of Erlenmeyer flasks for this. So transferring it into that, and then to rinse the whey paper, you will rinse it with the sulfuric acid, which you need to add about 100 milliliters of sulfuric acid. So just pour it down the whey paper to rinse all the solid out. Now we have 100 milliliters of sulfuric acid and our 0.1 to 0.15 grams of sodium oxalate, where you accurately recorded the mass in your lab manual. Now there are not any indicators for this. The potassium permanganate does its own indication work. It changes the solution. So this solution will be clear, colorless liquid. The stuff in the burette will be dark purple. So the potassium permanganate in the burette, you still have to condition the burette and then load the burette, making sure there are no bubbles or open spots anywhere, so it's completely filled. You're just going to make sure that the solutions that you condition with, you put into a waste beaker. So I guess now is a good time to say that there are going to be two different waste beakers for you for this lab. One will be for the pure purple potassium permanganate, lots of P's in that. So it's the purple stuff that did not mix with anything else. So pure purple stuff. So the stuff like when you conditioned your burette, that'll be with the pure purple potassium permanganate. You're going to put that into the waste beaker for potassium permanganate. That beaker can be small, like a 250 milliliter beaker. Your other beaker that's a waste beaker, I would have a large one, like a 1 liter beaker, and that's going to be for the reacted solution. So that's going to be for any chemicals that touched each other. So they've mixed together with something else. That'll be a much bigger container. Okay. So you'll need to check out your stir bar, and then you will add that to your beaker. Now, before the reaction can start, the solutions inside of the beaker need to get to at least 70 degrees Celsius. So the solutions need to be between 70 and 90 degrees Celsius. We don't want them to boil, so don't let it get warmer than 90. So you're going to have to turn on your hot plate. Now, at the beginning, especially at the beginning, I would get trial 1, trial 2, and trial 3 all prepared for part B and have all 3 of them sitting on the hot plate so they can all be warming. You're going to be using your thermometer to just periodically check the temperature. Remember, you use your thermometer. Don't let the thermometer touch the glass anywhere. It's suspended in the liquid to measure the temperature. And so once a solution gets to 70 degrees Celsius, you can start your titration. Now, it still has to be on the hot plate, and the hot plate still needs to be warming it, because while you do your titration, it has to be still between 70 and 90. So you'll have to arrange this to where the burette is directly over the beaker, you know, just where the beaker's a little bit inside of that. The stir plate, the stir function is on, so it's stirring. And then, just like any other titration, you will record the initial value of potassium permanganate from the burette. You will start adding the potassium permanganate. So what's going to happen at the very beginning? It's the best part of the whole thing. At the very beginning, the solution in the beaker is clear, colorless liquid. The solution in the volumetric flask is dark purple. When you add it, the solution down here is going to turn purple, like immediately, to where you think, oh my gosh, the reaction's over. No, it just takes it a minute to catch up. So what's going to happen is it's going to turn dark purple. But keep adding the potassium permanganate, and then all of a sudden that dark purple color is going to disappear, and it's go back to being a clear, colorless liquid. That's supposed to happen. Okay, that'll happen at the beginning of every titration with this lab. Now, once that's happened once, continue adding the potassium permanganate, but the second time the color changes is when we need to stop. So the color change is going to go from a clear, colorless liquid to a light pinkish purple color. Okay. That light pinkish purple color is our endpoint. So just like with our acid-base one, once you start seeing a hint of color show up down there, stop letting the liquid just drain, and instead stop and add a small amount of time. Let it stir, see if the color shows up. If the color disappears, add another small increment. We want this to be the lightest pink purple color we can possibly get. We need the color to stay for 15 seconds before you are at the end point. So if the color changes, but then it disappears in less than 15 seconds, you're not done. Add another very small increment. And then you have to keep doing that until the color stays for at least 15 seconds. With the acid-base one, it was 30 seconds. It's 15 seconds for this lab because we're at a higher temperature. These reactions happen faster, so less time. Okay. At the end of that trial, once it's turned that light pink color and it stayed for 15 seconds, take it off, remove the stir bar, rinse it, dry it, put it in solution 2, and then make sure it's at 70 to 90 degrees Celsius and repeat the titration. Okay. You're just going to do that for trial 1, trial 2, and trial 3 in part A, where each time you're going to see the dark purple color show up and then disappear. And then the second time you start seeing a color is close to the endpoint, and we're going to stop it as close to the lightest pink purple color that we can get that stays for 15 seconds. So you'll record the initial and the final value of your burette each trial. Okay. Part B, the only difference in part B is the solid that you're measuring out. So instead of measuring out 0.1 to 0.15 grams of sodium oxalate on your weight paper, you're going to measure out 0.5 grams of whatever unknown number you were assigned. It will be a solid. So you're going to measure out 0.5 grams and accurately record that. Pour that into your beaker for trial 1 of part C. Rinse it with the 100 milliliters of sulfuric acid. It needs to get to a temperature of between 70 and 90 from the hot plate before you can start. Once you're ready, add the stir bar, add your potassium permanganate until we get the light pink color. So you're going to do 6 of basically the same titration. It's just in part B, you're using sodium oxalate. In part C, you're using unknown. But the way that you do this is going to be the same for both of them. So you'll do your 6 titrations. The results of your 6 titrations all need to be poured into the giant waste beaker for the mixtures, the solutions that touched each other. Okay. At the end of the lab, you need to consolidate all of your purple potassium permanganate, so the pure purple potassium permanganate that didn't touch anything else, so like anything that's left in the burette, anything that's left in the beaker of the pure purple potassium permanganate, and then anything left in your waste beaker that had already been there. So you're going to have all your pure purple stuff in one spot, okay, in a small, like 250 milliliter beaker. And then you're going to have your 1 liter beaker that's filled with all of your reaction mixtures at the end of your titration. So what we need to do, your burette, even once you drain it, is going to be filled with purple potassium permanganate, and we don't want it to stain, and we need to get that out of there. So you're going to take the oxalic acid, which is that chemical that you're supposed to add to any spills, and you're going to rinse your burette with the oxalic acid, so that way all the pure purple potassium permanganate gets rinsed out, and you're going to drain that into the mixture waste beaker. Because we just mixed oxalic acid with pure purple potassium permanganate, so now it's a mixture. What we're doing is we're reacting the potassium permanganate to get it out of the burette. Rinse this until there's no longer any purple color stuck to the inside of the burette. Okay. Once that has happened, okay, you can put your burette in the designated container. Then take your waste beaker with the pure purple potassium permanganate in it and dump it into the designated waste container that says pure purple potassium permanganate only. So it's only the purple stuff, the dark purple stuff. You will go over to the waste container and dump all of your pure purple stuff into that. And when you come back, that beaker is still going to have some purple contaminants in it. We need to get rid of that. So you're going to take more oxalic acid and pour it into your beaker and dump that mixture into your waste beaker for all your mixtures until there's no more purple remnants of your beaker. At this point, all your chemicals should be gone, except your 1 liter beaker filled with all the mixtures. At this point, The oxalic acid has reacted, or the oxalate has reacted, both from the oxalic acid and the sodium oxalate, and the potassium permanganate has reacted. So our mixtures beaker is not hazardous anymore. I'm not saying drink it, nope, but I'm saying it doesn't have to go in the waste container. So all we have to do at this point is neutralize this to a pH of 6, 7, 8, or 9, and then pour it down the drain. So we're going to neutralize it just similarly to how we've neutralized other chemicals in this lab. It's just we will be having to add a base to this. The base we are going to add is actually real classy and fancy. It's pool neutralizer. So we're going to just be adding this solid base to this to make it react. Now, when the pool neutralizer mixes with our mixture, it makes a carbon dioxide gas. It makes CO2, so it makes bubbles. So you're going to have to pour it in small amounts at a time until the bubbles stop forming, and then check your pH. It should be 6, 7, 8, or 9. Once you've reached that, this solution can be dumped down the drain, and then the beakers can be washed, and everything can be washed and put away. You will need to, when you return your burette to the designated container, forgot to mention, you will be removing the stopcock and the tip and dropping it into a beaker that's labeled filled with oxalic acid, because this is really hard to clean out. It's very narrow. So we're going to let that soak. And then all the rest of your glassware you can just wash and put away, except for the stir bar, which you will wash and then return to the stir bar container to check it back in after you checked it out at the beginning of lab. So the thing that's the most time consuming for this lab is honestly getting the solutions to the 70 to 90 degrees Celsius before you can titrate. But don't think that you're smart by turning your hot plate on early. Do not turn your hot plate on until you have a beaker on it, because what will happen is if you turn your hot plate on early and then you set your cold beaker on it, it's going to break the beaker and the solution's going to spill everywhere, and this is not the lab to make big spills. So don't turn on your hot plate until the solutions are on it. Then you can turn on your hot plate. And don't crank it all the way up, because again, we do not want this to boil. We want it to get to 70. 70 is the ideal temperature for this, but it can be between 70 and 90 for this to work. Be careful about keeping your two waste beakers separate, and ask me if you have any questions ask your instructor if you have any questions about this as you're doing it, especially safety related things. Don't forget to read through the safety data sheets and complete the required safety quiz that's part of your lab manual before you come to lab, so that way you've seen all of the concerns with the chemicals. Okay. So for the background theory and calculations, watch the other video for the reduction, oxidation, titrations.